Section 4.3, Modeling Linear Trends. Okay, a regression line is a line drawn through your scatter plot that comes the closest to all the points. It's a tool for making predictions about future observed values. Recall from algebra that the equation from a line looks like y equals mx plus b, where m is the slope and b is the y-intercept. Statisticians use the same basic structure, but they reverse it just a little bit. They write it as y equals a plus bx, so they've just reversed the ordering of those two terms. B is now the slope, the number in front of the input variable, and a is your y-intercept. Again, recall, you've probably studied this in the past, but recall that slope measures the steepness of the line. It's the rate of change of y as x changes by 1 unit. So they're going to have questions where they want you to interpret what the slope means. A good structure for that, a good sentence to use, you just fill in the blanks with the context from your question. And what you'll say is, as the x, whatever x is in your problem, as the x increases by 1 unit, we expect the y to increase or decrease by whatever the slope is. And we'll do an example about that in just a minute. The y-intercept is where the graph crosses the y-axis, and it's where the x-coordinate is 0. So y-intercepts have the form 0, comma, something every single time. A couple new definitions here is what we would call the explanatory variable. That's just a new stats word for your x variable. They also might call x the predictor or independent. And your response variable is just another word for your y. Y is what is being predicted. It is the dependent variable. Okay, so here's an example of a regression line, and this is actually an output from StatCrunch. So again, here's your line. This is the equation of the line. Predicted RBIs equals 30.46 plus 2.16 home runs. And again, they don't put any symbol here, but what's happening right there is multiplication. Okay, so here we've got our image. Here's our scatter plot down here. They've got that line, that regression line drawn on it. And then they want us to answer some questions. What is the explanatory variable? So again, it's a new definition, but what we just need to remember is that explanatory is the x. So in this case, our x variable would be down here across the bottom. That would be home runs. And the response is just another word for y, so our response is RBIs. What is the slope of the regression line, and interpret what it means? Okay, so we have to be able to look up here at the equation and know which of those numbers is slope. Slope is always the number in front of the quote x variable. So in this case, the slope is 2.16. And now we want to interpret what that means. So I'm going to use this sentence structure from up here. As x increases by 1 unit, we expect y to increase or decrease by the slope. So I could say something like, as home runs increase by 1, so for every 1 new home run someone hits, we expect the RBIs to increase by 2.16. What is the y-intercept of the regression line, and interpret what that means in context. Okay, so the y-intercept is always of the form 0, comma, whatever the y-intercept value is. So again, if I go up and look at my line, that other number is right here. It is the 30.46. And the reason why I like to write it as a point is because then I have an x and a y value. And if I just explain what each of those mean, I have my interpretation. So x here was home runs. So I could say something like, even when a player has 0 home runs, we still expect them to have 30.46, and that's my y variable, and my y variable was RBIs. So even if a player has no home runs, we still expect them to have about 30.46 RBIs. They're going to ask you in your homework problems to interpret these two. So there is an example right there of how to write your sentences or what kind of sentences you should be looking for. Okay, how many RBIs would be predicted for a player with 18 home runs? Anytime you're predicting, if they want you to predict, you're going to go up and use that regression equation and sub the appropriate numbers in the appropriate places. So I'm going to remind myself of what that is. RBIs equals 30.46 plus 2.16 home runs. And here they want to put 18 in as the home run. So I'm going to move that out of there. And I'm going to put 18 in right here. And then I'm going to use my calculator. And I'm going to calculate that out. And when I do that, I get 69.34. So I might say about 69 RBIs. Oops, RBIs. And that's how we use our regression equation to make predictions. Now it says, note, the order of the variables does matter here when finding the regression line. Remember, in the last section, we talked about how reversing your variables does not change the R value, but it will change the regression equation when the variables are reversed. Why does this happen? Well, all of your points have now moved. So the line that best fits them will be in a different place now. So this is something very important to keep in mind. The regression equation will change even though the strength and that R value won't. Another note for linear trends, if the slope is close to 0 or equal to 0, we would say that we have no association between those two variables. Again, correlation is not causation. We are looking for relationships between the two variables, but just because we find an association does not mean X causes Y. Can't say that enough. Okay, for our second